Assalamu alaikum wa rahmatullah. I am very excited to be here, and thank you very much to ISA Saudi for inviting me and giving me this opportunity to talk about predictive emission monitoring system. Starting my presentation, I will give you overview about the main points which you will see in the next slides. I will start by introduction and give you overview about this technology. Some of you are already aware of it, but I will try to give much more simple explanations to it for those of who are not much familiar with it. And then we will give an overview about features, benefits, challenges, and a short summary at the end of my presentation. First of all, I'm the regional manager of Dura Group, which is a family-owned company based in northern part of Germany in the city of Hamburg. And we are mainly in safety monitoring and emission monitoring. These are the two pillars. Many of you might know our flame scanners, igniters, or opacity monitors, and also SAMPs, which is the sister of the topic of today, PEMS. PEMS is a software-based solution for emission monitoring, for continuous emission monitoring. And as we are in this conference, the main topic is about digitalization and emission. So PEMS is the combination of both for industrial emission monitoring. And the main advantage of it, the main benefits is that you can replace the gas analyzers. And I will start by asking the questions, how many of you, just please raise your hand, are working on analyzers here? Just please raise your hand. Anyone familiar with SAMPs or PEMS? Very good. I see many hands. Very good. So what I am introducing here is not new. But what I want to give you is the experience which we want to share with you, how you overcome the challenges which are there with this technology and how you can make it beneficial to replace any SAMS gas analyzers which you might have and you might have challenges with them. Just to give you first overview, here on the right side, you see the traditional system, where you have gas analyzers, sampling systems, and on the left side, you see the PEMS solution. As example here, the Durag data SAMS, and you can imagine that on the right side, when I'm having gas analyzers, I face a lot of issues with the sampling system, with the gas analyzer itself, with the calibration, and with the maintenance of it. The first question to answer, is this approach accepted worldwide? And the answer is yes. There is a standard in US EPA, Environmental Protection Agency, the code Federal Regulation 40 Part 60 or Part 63. These are the two major ones which are implemented outside of US. 75 is more stringent. Therefore, we advise it mainly for companies inside US itself, because there are a lot of very stringent requirements which often cannot be met by companies outside US. Just to clarify, there is also something called simplified PEMS. This is a light PEMS where you just get 3 different process factors or less, and is often used for flare monitoring. But this is not qualified for environmental emission monitoring. So just to make clear that this is not the PEMS which I'm talking about here. It's just use it for indication, but it is not for reporting. You cannot use it for reporting to Royal Commission or to the environmental authority. It's just as indication, or in case you do not have enough process information to make a sophisticated PEMS model. How is the model built? There are 4 different stages, starting with the creation of the model, of the PEMS model, and ending with the finalization and implementing of the system in your plant. During the first stage, we need to collect the data. And how are these data collected? You need a mobile SAMS, a mobile gas analyzer, collecting the data from the stack. And there are specific requirements, and I always urge and remind our clients to look into the performance specification 16. It's just 20 pages PDF file from US EPA. It's very simple, and it describes what's required to collect the data and how the load has to be variated, because you cannot collect data in a load and then you expect your PEMS to be. And the same also with the type of fuels. If you are changing your fuel, this has to be incorporated within the PEMS modeling from the beginning also. And in the finalization stage, of course, the PEMS has to be sealed against any manipulation, because the Environmental Monitoring Authority wants to be sure that this data is true and that there is no manipulation from inside the plant itself. There are 3 different categories of the process inputs which are required to build this model. The first part, the most important one of them, are related to the load and to the fuel flow, the fuel-air ratio, and the second level is the important ones. The important ones includes, for example, the temperature, the pressure, and then you have less significant ones, which are helping us to make the model much more accurate, much more robust. And this, you can get the data from your weather station, including, for example, the humidity or the temperature outside, because these have some effects also on the reading of the system. This is just one example for a gas turbine, the different process parameters which are selected there. And here to give you overview about the PEMS envelope. The PEMS envelope, you identify the main factors, the main process parameters, the minimum value and the maximum value. And when the sensor is reading something which is outside of this range, then it is, of course, cannot be considered in the software itself. And as soon there are more than 2 or 3 sensors failing, the calculation of the software has to give you a warning that there is error. Because when my load, for example, is over 100%, something is wrong with this sensor. And the reading has to be also blocked at this point of time. And of course, most of these parameters are also important for your process, and you want to know about them, and the system is checking them every minute. Every minute, the sensor validation component, this is part of the software, is active and checking the data. So the main features of PEMS is that it is usually used for compliance. You want to demonstrate to the emission authority or to the environmental department that your stack is within the limits. This is the main target of PEMS. However, it can be also used as a backup of your existing SEMS, continuous emission monitoring. And in the past, there are also some simple PEMS which are included by the gas turbine manufacturers, because they want to make sure that their gas turbines is within the emission target which they have. But this simple PEMS is not qualified for emission monitoring. Just to give you an example of PEMS software, I've selected here the one from Dura Group called DataSEMS. This is based on multidimensional mathematical modeling and using correlation and chemical formula of the gases which are coming out of the stack. NOx, SOx, methane, H2S, whatever is coming there, there are some formula, there is some regression between the parameters, between the load, between the fuel composition, the fuel-air ratio on the one side and the outcome of that side. And it is a learning software. The more accurate input you put in this software, the more it's more sophisticated. And it can be as 99% accurate as the gas analyzers which are used in the first place to build them. And I really like what Mr. Ali Dosari mentioned before, that the software that this monitoring or artificial intelligence, it's only useful as the data which you give in it. If I do not simulate the load or the fuel changes in my model, in my building model, the software cannot master this case also. So this is very important. The main benefits of PEMS is, of course, the saving. Because less human power is required, less cost on the gas analyzers, less cost on the maintenance. This is the first main advantage. The second advantage is the availability, because it's a software and it's available continuously. Where with the gas analyzers, there are some colleagues here from SEMS, they know that the gas analyzers are not always available. And especially there are some very challenging applications where the temperature is very hot, where the stack is old, and I do not have a platform to install my gas analyzer there. These are the cases where we advise to consider PEMS. Just to give you some numbers, the capex is something around 40 to 80%, and I want to underline this point. Please do not go for just simple PAMs, because I have seen many end users implementing PAMs, and after a few years, when I talk to them, they are facing a lot of challenges with them, because it's not about price. It's about the right solution for you and the right project management also. And I will talk about this in the challenges. So the lifetime cost, when you compare the investment of PAMs to the SAMs, it's roughly 30 to 40%. The main challenges, as mentioned, please treat this as a challenging project. You need to involve all the departments in your plant, starting from the IT department to the emission monitoring department, analyzer department, but most important, this project has to be supported by the higher management. Because when we are building the models, we need the plant load to be variated. And we need also in that time, in that slot of time, we need the different fuels also to be there. Because otherwise, we build the PEMS model, and later on, it's not matching. And one other point, each stack has its own PEMS model. Even if the stacks are similar, please do not use the same model for that stack. So this is something which we have seen that clients want to save on that, and later on, after 1 or 2 years, the software is drifting very much. I'm coming to the summary. First of all, PEMS is not new. It's already there in worldwide. And I know that Aramco is using it in different plants. SABIC is a little bit reluctant, because the Royal Commission, when I visited them in Yambo and in Al Jubail 10 years back, they told me about, we do not trust PEMS. But in case there are SAMs or stacks where the reading of the gas analyzers are not matching at all, only in that case we are allowing PEMS. So the current states, maybe they are allowing it. What I can tell from my experience is that United Arab Emirates, the ADNOC, we worked with them 7 years back on FEED, and we made their a demo project, and now we see all the affiliates of ADNOC bringing new PEMS projects, more than 400 or 500 stacks. All of them are going to be PEMS, and they do not want to use SAMs anymore. And Kuwait is also starting on that, and we are here to support you in case it's required. We have our local partners here in Saudi Arabia, and myself, I'm coming the way from Germany here to see you, because you are our friends and our very close clients. Any case, when you have questions, please let me know, and thank you very much. Any questions?
Yeah, thank you very much, Abad. This is Ahmad. It's very informative presentation. My question is regarding the emissions, which you said NOx and CO. These are typical non-linear behaviors, right? So the application you're using has the neural network-based capability or not? That's the one thing. Second part is, which is very important for PEMS, you mentioned on data substitution actually. So how do you actually do the data substitution?
Yes, thank you very much for this question. And you are right, it is not linear. Therefore, I mentioned multidimensional mathematical modeling, where you are using the chemical formula, but also regression and learning of the software itself. So it's not just using Excel and putting a formula there and you get it. It's learning. And we are using the data gathered by the gas analyzers, and we are comparing them with the output of the software with the actual reading. And this has to match at least 90%. This is the requirement from US EPA. Thank you.
And regarding substitution?
Yes, I mentioned software validation. If one of the sensors is not working, the software is able to substitute it. But this you can do only with one parameters, one of the significant parameters. If there are more than one important sensor failing or giving you a value out of the envelope range, then this is a major error, because you do not want your software to calculate based on that. So you will get a warning. Thank you. Any other questions? Thanks a lot.